So here in this diagram, you can see in mobile network, this is the part of an access network. So all these appliances, mobile devices, mobile appliances can connect first to the cellular tower, and then this cellular tower is provided an access to the first edge router. Likewise, here also in the home network, here this home is connected to the regional service provider through the telephonic line. Here also it is connected through the telephonic line. So these both home networks are connected to the same local or the regional internet service providers, and they are connected through digital subscriber line. So there, with this technology for accessing the network, there at both ends you require modems. These modems will convert to your digital signal into analog signal and back to analog, from analog to digital, and vice versa. And so here for providing, so there is also one router here, but it is internal to the network. It doesn't have global presence. This device doesn't have a global presence. Global presence means it doesn't have a global IP address. Whereas here in this case you can see, so we will consider an edge router only the first one towards the destination which has the global presence or the global IP address. So here in this mobile network, it has a global IP address, whereas this doesn't have a global IP address. Once we will start studying the IP addressing, then you will understand that there come certain addresses, the address range, which are not global. Global means the global routers will not recognize, will not route the packets if ever a packet reaches with those organizational addresses. So those organizational address ranges or the home address ranges. So if you would have ever recognized addresses starting from 10.0, 10.1, 10 dot something, the addresses starting with 192.168 something, and there is one more 172 something dot. So there are three ranges. If those ranges addresses are there, so those are internal to the network. So outside uh, means the network core or the edge routers can't have those type of addresses. Why there is organizational addressing concept is there, everything will understand once addressing will start. But this is that sort of a router which also has an IP address, but must be somewhere in the range of either something 10 dot something or 192.168 something, and then it is providing an access to all the appliances first connected to it. So it must be connected either through Wi-Fi. So these devices are this device is connected to this router which is internal to the network through Wi-Fi. So there is a Wi-Fi modem here, and it is directly connected, must be through Ethernet. Likewise here, and here in the enterprise network, so these routers, here in this enterprise network, you can see this is the part of an access network. This is one LAN which is accessing this network core through this router. So this is the edge router for these all appliances which are the part of single LAN. These these three devices are connected to this wireless access point, which is the part of the same LAN network. And then in the enterprise, they are maintaining their servers. So they don't want to clutter their servers over on the same LAN. So for that purpose, they have secured them in the different LAN. And these servers can access the infrastructure or the core network through this edge router. And then these two edge routers are connected to this router, which is these all routers have a global presence. So global presence means the global IP, they hold the global IPs. Then there are different technologies through which subscriber can have an access to the infrastructure network or the network core. One way is dial-up modems. Another is, I'm telling you in terms of the chronology. Initially, uh, when access network designers started thinking about designing something for accessing the core network, so initially they looked for something which were existing at that time in terms of networking. So at that time, telephonic networks were there all across the places, and cable networks were there, particularly in Europe and to America. So they looked for an option that either is it possible that through the existing infrastructure there is a possibility of accessing the network core. And then they designed initially the dial-up modem, and the dial-up modem is a simple device. Suppose if you are a subscriber to any telephone exchange, you have a number in place, you have a phone in place, and you want to access the network core. So your telephone exchange is a part of that network core, but you require some sort of a technology which will allow you to transmit your data or retrieve data from the telephonic exchange over the same existing wire. So then initially comes the dial-up modem. If you will install that dial-up modem along with your device, along with your phone, so that dial-up modem will initially engage the line for you. So over that line, then only data communication is possible, no voice communication. So with dial-up modem, the constraint is that at a time, either you can transmit a voice over it, or you can transmit data signals over it. So either the data communication or the voice communication. And in between, if the data communication is going on and you receive a call, so if that call starts, if that will engage the whole communication, and then whatever be the data over the wire and whatever the communication is going on, that will be stopped abruptly. So that is the constraint, and those are all the challenges, and even the speed was not up to the mark with dial-up modems. Then there comes the digital subscriber line, the same telephonic line, but it's a sort of an advanced technology. They divided the channel, they divided the same line in three different channels. One channel is exclusively for voice communication, and other two divisions, one was for downloading the stuff from the telephone exchange, and another was to upload it. And they divided these channels based on frequency. So for voice, frequency was different. So a high speed downstream channel in the range of 50 kilohertz to 1 megahertz, then an upstream channel for from 4 kilohertz to 50 kilohertz, and a simple normal two-way telephonic channel for voice transmission that comprises of the range 0 to 4 kilohertz band. So that is DSL modem. If you will go more into detail that how they were being able to do it, so for that purpose at your home side you require a DSL modem which will convert your digital signal into an analog signal, and whenever the analog comes, it will convert back into digital signals. And there you require a sort of a splitter which split the frequencies. So if there is a voice communication, the splitter has a task to differentiate that to what is the data communication, what is the data, and what is voice. So it will it's sort of a differentiator or a splitter in voice and data based on frequencies. And in the central office or in the telephone exchange, the same thing, the division part, because your telephone exchange is a part of big internet, because they are providing internet services. So they are the part of big internet, or they are connected to other internet service providers. So they have one channel for that, and they have another channel where the traditional telephonic network connections do exist. So at the central office, DSLAM, and it's digital subscriber line access multiplexer. So here also the job is same, sort of a splitter at your end. They divide, so but on a big scale, because there are several subscriber and DSLMA has to do it for all the subscribers. So that's how a home network can have an access to the internet service provider, and systems can have an access to the internet service providers. Likewise, the channel is copper wire. In case of cable network, it is coaxial cable. Then in case of fiber to home, this is optical fibers there. Fiber to the home, so there the channel, the concept is different. Obviously, if you are using optical fiber, there you require LEDs for generating optical waves. Whereas in case of copper wire, the modem technology will definitely differ from the coaxial cable, which is there in the cable network. But more or less the idea is same. The same existing network, in case of the cable network and the telephonic network, were used for accessing the infrastructure network, the main network, the core network. So we'll not go into detail regarding all these coaxial cable technology, but more or less the idea is same. You have to divide in case of coaxial cable, this there here in case of cable internet access over the same wire. You have both video upstreaming or downstreaming, and as well as data upstreaming and downstreaming. So there must be some sort of a differentiator. So that differentiation or that splitting will be handled at the fiber node, and at the main end, or at where all the subscribers are connected at their central office. So this must be done somehow through CMTS. So that is regarding cable. And then fiber to home, so there's no point in going, because that's the part of data communication. So if you have interest, you can go through on the text, but more or less the idea is important, that how an access to the infrastructure is possible through different technologies, and their services in terms of providing bandwidth, delay differs a lot. In case of optical fiber, it's the best service, because there you will get minimum interference. Whereas in contrast, if you will see the copper wires telephonic network, maximum interference there, whereas the interference is less in case of somewhere in middle in case of cable wires, but there you will not get higher bandwidth. Whereas in case of fiber optics, you can get the higher bandwidth as well. The delay will be less, interference will be less. Then in case of home networks, in case of home and enterprise network, you can have an access to the first router, the first edge router, or through Ethernet or Wi-Fi. So Ethernet, the standard IEEE standard is 802. I think 11 or 3, sorry. Wi-Fi it is 11, 802.11. For Ethernet it is 802.3. That is the IEEE specifications which governs Ethernet standards and Wi-Fi standards. So here in case of Ethernet, you require a switch. So behind switch, whatever comes, that will be the part of same LAN. Once we will delve into the link layer, then we will understand the importance of switch, what switch will do. Already in one of my lecture, I have mentioned about the Ethernet switch operation. What Ethernet switch operation will do, it will reroute the packets which been received at one of its interface using through uh, physical addresses, MAC addresses. So suppose this device wants to communicate with within the LAN. So what this device will do, suppose this device wants to communicate with the server, which is over the same LAN. This device will send a packet, and then this Ethernet switch will look for a MAC address where it has to send it. Then it will look for a MAC address and find that this server is connected over this interface, and it has the same MAC address which this device is looking for as a destination. Then it will reroute it. So it has to maintain certain tables, that is called ARP tables, address resolution protocol tables. So Ethernet switch will maintain those tables. So, and based on those tables, it will reroute the packets. If instead of switch, it would be a hub, then hubs are not intelligent. What hubs would have done it in that situation, after receiving it over any of its interface, it will reroute it to all other interface, irrespective of whatever be the physical address written on that frame. So then obviously the communication will be more, traffic generation will be more, because so suppose if it would be a hub, it would have received one frame, then it could have duplicated those packets, and 1 2 3 4 5 over 5 other interfaces it could have rerouted it. So it will multiply the traffic generation. That's why hubs are no more in use. We have moved to switches, and switches are intelligent. They learn all these things over a period of time. Initially, though, they start with the same operations as hub do, but they keep on learning over a period of time. So how they learn it, that is a part of a protocol, and that protocol we'll delve into once we will start uh, reading about and understanding about layer 2 or the data link layer. So that is the Ethernet. So Ethernet also use twisted cable, twisted copper wire cables, and all of us now are using the Ethernet for accessing our internet, for accessing our edge router, and most of the places, particularly even in homes also, we are using it to Ethernet. Even if you are using, so here you can see that even if you are using DSL cable or any of the things, you are connected to switch or router first. So you are making your own LAN, the home LAN, and then the technology may differ. So you have your router has encapsulated the technology for you. So the technology hardly matters to you, but how you are accessing even within your home network, you are accessing it through LAN. So all these three appliances already, I think in one of my lecture I have mentioned, these three things club together, and they call it a router, which you use for accessing your service provider. So that is the part of that is Ethernet, and then likewise the Wi-Fi. The standards are different, but more or less their working paradigm, working style is same. So Wi-Fi just allow you to be mobile. So there you use in case of Wi-Fi and Ethernet, the difference is over the Ethernet cables you use electromagnetic waves to send at the physical layer, whereas there you use the same but in radio waves you will send. So obviously that is all, radio waves are also the part of electromagnetic waves, but only the frequency differs. What you will send over the physical wires, that frequency will differ from what you will send wirelessly. So when that thing differs, so there comes different protocols to engage with all these things, but that difference is more or less on medium access control layer, that is data link layer, because there you have to access the medium. So if you are using an Ethernet wire, so the protocols for accessing the Ethernet wire will differ from the protocol which will access the air medium, because both mediums differ. One is guided medium and another one is unguided medium. So the protocol for accessing the medium differs. So both the technologies, Ethernet technologies and this Wi-Fi technologies differs in terms of accessing the network, how you will access the link, how you will access the channels. So there it differs. So their medium access control protocols differ. So they both differ at the layer 2, and particularly in terms of accessing the mediums. So that's all about accessing the edge router. So this is a typical home network. So here you are accessing the edge, internal edge router, and here I think they are using the coaxial cable for accessing the home network to the internet. In my first lecture, when we were discussing about the mobile network, how the mobile devices were connected to the cellular network, cellular tower, and then cellular tower was connected to the edge router. So how we can access uh, and how as a mobile device can connect to the cellular tower. So there are different cellular technologies. Initially cellular technologies were only for voice communication, so 1G. If you will focus only on 1G and figure out that 1G was solely for voice transmission, then they added data along with voice, then comes 2G, then 3G. So if you will relate to and to compare the progression of all generations, 1G and 2G, the difference is they introduce data also, but over a period of time it is in terms of providing more bandwidth, more connectivity, lesser delay. So these technologies evolve. So uh, all these technologies, so if you're interested in, you can take the course on wireless communication. Probably in next semester or so, you will get an option as an elective for that. There you can have an access to all the resources regarding all the generations of wireless connectivity, wireless network. So from this course perspective, uh, you should only be concerned and bothered about that there's a sort of a technology, wireless technology, which provide wide area wireless access. Whereas if you will compare this with Wi-Fi, Wi-Fi also provide you an wireless access to the edge router, but The difference is the range is less. Whereas in case of wide area wireless access, so the range is more. So there, if it is in the ratio of 20 meter, 10 meter, there it will be in the ratio of 10 kilometer, 20 kilometers. So within the range of 10 kilometer or 20 kilometer, you can have an access first to your cellular tower, and then from cellular tower, it can connect you to the edge router. So that's the only difference. 3G, LTE, now even 4G, 5G. So many things are there, but that is not the part of our syllabus. I think this much is sufficient for you to just understand the cellular technology for accessing the edge router, and then finally to the network resources or infrastructure network. There's different physical media. Already I have explained it. Once again, I don't want to delve into it because all these things are the part of data communication, which is also not our area of expertise, where you have to delve into detail. And physical media, like you can have a twisted pair copper wire, which is generally called unshielded twisted pair, UTP pairs. So that is used along with Ethernet. Then coaxial cable for your cable connections, fiber optics, so is the best one. And then terrestrial radio channels, this is for air communication, unguided communication. Then you have satellite radio channels. So that's all. I think this much is sufficient regarding physical cables and all. You don't have to worry too much about it. The idea is, the focus is more on access network. There are different technologies and how you can access the edge router, how you can then finally connect yourself to the network core. In the next lecture, we will understand about the network core. There we will understand packet switching and circuit switching in detail.